Hello, everyone. Welcome to the first answer hour on OpenBridge Designer. Today's topic will be tips on steel and concrete bridge rating. And I would like to introduce myself as the first presenter, Vinay, and the second presenter will be Ana Carla Perez. Today's agenda, we'll have a discussion about OpenBridge Designer overview. Then I'll have a brief introduction about rating and manual for bridge evaluation rating equation. After that, I'll take the topic on lead bridge concrete, precast girder, and post-tension box girder rating workflow. And a brief discussion on the common queries from the users, which we've been getting over a period of time. After that, we'll have a discussion on lead bridge concrete, lead bridge steel, composite steel girder rating workflow, and related queries. Finally, Anna will give a presentation on RM bridge composite steel girder rating workflow and discussion on common queries. Finally, we'll have a Q&A session wherein the audience can post their questions. Regarding the queries, they can post the questions on a regular basis on the Q&A window as well. So, what are the expected outcomes of this presentation? The first topic I would like to discuss about is OpenBridge Designer, a brief overview of the product. What exactly is OpenBridge Designer? We have two workflows in OpenBridge Designer. One is the BIM workflow, and the second one is a standalone workflow. In the BIM workflow, the user can follow a procedure where they can model the bridge in OpenBridge modeler, and then they can export the model to lead bridge concrete, lead bridge steel, or RM bridge, and they can continue with their analysis and design and rating of the bridge. In the standalone product, in the standalone module, the user can model and analyze the design and rate the bridge individually in each module separately in lead bridge steel, lead bridge concrete, and RM bridge. So in the next slide, you'll be seeing the workflow from OpenBridge modeler where the modeling is done. Then the same information has been exported to lead bridge steel, lead bridge concrete, and RM bridge, where the analysis and design and rating is performed. So the next topic I would like to discuss is lead bridge concrete, wherein I will go through the workflow for precast girders and post-tension box girders. We'll discuss about the hand calculation and certain common queries raised by the users. So what is rating? As everybody knows, bridge load rating, it provides a basis for determining the safe load capacity of a bridge. Load rating requires certain engineering judgment in determining a rating value that is applicable to maintaining a safe use of the bridge and arriving at a posting and a permit decision. The specific load ratings are used in identifying the need for load posting or bridge strengthening. For example, if there is any spalling of concrete or if there is any defect or a hole in the girder, those kind of information can be added in the program, and the rating can be calculated to see if the bridge has enough strength to take the load or not, and also in making overweight permit vehicle decisions. So as per manual for bridge evaluation code, the rating factor equation has been provided in article, which is 6A.4.2.1-1. The equation is pretty simple. It's a capacity minus the load factor times the dead load divided by load factor times the live load. So regarding the first program I'll be discussing is lead bridge concrete precast prestress girder module. Previously we used to call it as conspan. As you can see in the screenshot, the bridge two-span bridge has been modeled in lead bridge concrete, and the same information has been transferred to modeled in OpenBridge modeler, and the same information has been transferred to lead bridge concrete. Here you can see the 3D view of the model. So what are the different types of live load lead bridge concrete precast girder module can handle? Under design load rating, we can run design truck, double tandem. Under legal load rating, 3-3-3-F1, 3S2 legal load. And under permit load rating, P11, P13, P15 permit truck can be run on the the program. And also the users can customize their vehicle, and they can run the vehicle in the program, and they can get the design as well as the rating information. So in the next slide, we will go through a video wherein I would like to show you the procedure on how to rate the program in LeapBridge Concrete Precast module. So once the data is transferred to LeapBridge Concrete, you can click on the module, Precast Girder module, and you should be able to see the cross-section view in the geometry tab. And the whatever the girder has been modeled, that's been imported into the beam section library, and it's been saved in the library. Or if you want to change the girder type, that information can be changed there and saved in the library. All the loads have been imported from the OpenBridge modeler. All the live load is assigned to the girder, to the bridge, and then the analysis is performed. So just click on Run Analysis. So all the information is populated in that particular tab. Then the design of the girder is done. So the program performs the design using a combination of draped and straight strands. So in this case, I'm just trying to keep it simple, wherein I'm changing from the drape to straight. So once all the design is safe, you can copy the same information to the remaining girders. It's pretty easy. The procedure is same. So once the girder is designed for flexure, we have to design it for shear as well. So you need to go to the shear tab, select the stirrup size and auto design, and copy the same information to the remaining girders. So if you have any negative moment over the pier, you need to assign some rebars there just to counter that additional negative moment, and the same information can be copied to the other girders, on the top of other girders. So if the user wants to see the results, the stresses, the moment, the shear values, the ultimate capacity results, so those information can be obtained in the results window. As you can see, if you click on the positive envelope stresses, you can see the positive stresses and negative stresses in that particular report. So next is the rating. So once the design is done, the user has to perform the rating. They can select the vehicle under design load rating, legal load rating, and permit load rating. And they can select the rating options they would like to get the report for. There are two types of report type. One is basic report. The other one is the FDOT report, which the user can select. They can click OK. And if they click on rating results button, the program will generate the rating report for inventory, operating, for legal and permit vehicles. So you can see the ratings for moment, shear, longitudinal reinforcement, concrete tension, concrete compression, and pre-stress tension. So if the user selects the FDOT report, then the program will generate a specific report which is as per the FDOT requirement. This is the summary report which is as per the FDOT requirement, and also the program will generate calculate the shear as per the FDOT requirement. The user can save the particular report in a PDF format, and they can submit to their client. So once the design, the rating is done, user needs to update the file, and they have to save the file, give a name to it, and all the information will be saved under OpenBridge Designer. So going over to the next slide. I would like to discuss how to read the report here. Under basic report, the program generates the inventory report under strength 1, service 3, and service 1 limit state. And for operating, the program generates a report under strength 1 limit state. Also, the user can get all the allowable stress information, which has been shown in a different tabular report, as shown in the screenshot. So in the next slide, I would like to discuss how the hand calculation is done. For shear, I'm trying to calculate the rating factor for shear at 0.2 L, and for moment, I'm calculating the rating factor at 0.5 L, which is the midspan. So The program picks the moment and shear value at each POI from the shear and moment envelope report. The moment capacity is obtained from the ultimate moment report, and the shear capacity information is obtained from vertical shear capacity report. So these are the information which are obtained at each and every POI for individual loads, and that information can be used. Generally, the program picks internally to calculate the rating factor. Here you can see the calculation for the moment rating factor at 0.5 L. So I'm getting all this information from the report, the dead load, the live load, and the moment capacity. So I'm plugging this number into this equation from MBE, which is this equation, and I get a value of 1.98, which matches Conspan. The same information is obtained for shear as well at 0.2 L, and all the information is obtained from the shear and moment report, and it's plugged in into the rating factor equation, and finally the rating factor is calculated. So in this case, both the values are matching Conspan. So these are the load factors which are used, and the resistant factors which are used in this particular equation. Also, the program generates the report for legal live load rating under Strength 1 and Service 3 limit state, and for permit live load rating, Strength 2 and Service 1 limit state. And as you can see, there is a red flag here which shows 0.62, which is less than 1. That means the girder is failing at that particular POI. The user needs to go back, reassign few more stirrups there, and if there is failing due to moment, maybe add few more strands and reanalyze or re-rate the girders so that the red flag goes away. So that was the basic report. As I mentioned before, we have one more report, which is FDOT report or Florida DOT report. And there is one more option under FDOT report where the user can calculate the shear capacity calculate the shear reinforcement across failure plane as per FDOT alternative. So here is a summary report which the program generates when this particular option is selected. And also how the shear capacity is calculated. It's a different procedure than what actually the conventional procedure is as per AASHTO. Here at a particular critical section, the program calculates the distance of the shear failure plane using the equation 0.5 dV cot theta and 0.5 dV cot theta to the left and to the right of the critical section. The number of stirrups which are located in that particular failure plane is been calculated internally, and finally the total area of the stirrups is calculated. Using this total area of stirrups, the shear capacity is calculated for the stirrups. The shear capacity due to concrete is calculated. Then VN1 and VN2 is calculated as per equation 5.8.3.3-2. Then the minimum of VN1 and VN2 is calculated, and finally the shear capacity is calculated. This method is quite different from the conventional method, which is as per AASHTO. So these are some of the queries which we have got over a period of previously through forums, through users. So some of them are like, how is the longitudinal reinforcement rating factor calculated? This is actually based on equation 5.7.35-1 and -2. It's actually the ratio of APS times FPS to the right hand of these two equations, depending on their applicability. All the values used for longitudinal reinforcement ratios calculations can be extracted from the vertical shear and ultimate moment report, which I have shown you previously. Also, rating at bearing location for shear. This is an option under basic report and FDOT report. Previously, some of the users wanted the rating to be shown at the bearing location for shear, and there were some cases wherein the user did not want it to show the shear rating factor at a bearing location. So just to avoid the conflict, a new option was provided to the user wherein user can check in and uncheck that option to get the kind of report or which is required as per their client. The option is available for both basic and FDOT report. The rating of design lane load, this is quite common query from the users. The rating for design lane load is done internally in the program, but as per part of the HL93 truckload, and the rating of the design lane load is not shown separately in the output as it is part of the HL93 truck rating itself. So how do you, the other query is, how do you turn off the red flags for moment K? What is the K value? It's basically if the concrete member does not satisfy the minimum flexural reinforcement provision as per LRFT design article 5.6.3.3, wherein the user has to have the flexural resistance reduced by multiplying by a reduction factor of K, where K equal to MR divided by M minimum. MR is the phi, Mn, which is the capacity. M minimum is a lesser of cracking moment, or 1.33 mu. So we do show the K value and the moment times the K value here. If it's in the red flag, if that option is unchecked, the red flag goes away. So how do you rate a single permit vehicle on bridge? User can select the concerned permit vehicle and then input the permit factor as per MBE table. This is a table 6A.4.5.4.2A-1. So you can get the factor here, and they can input that factor in this rating parameter dialog box, and they can run the rating analysis and get the required value for permit.
Thanks for watching. If you found this video helpful, please give it a like and share it with others. If you want to see more like it, please consider subscribing to this and Bentley's other channels. Thank you, and see you next time.